Hi, Adam. Welcome to the podcast.
Yep, thanks for having me. This is something that we've been talking about for a very long time, and I'm glad we finally made it happen.
Yeah, and unbelievably, it's your first ever podcast. So I'm quite thrilled to have you
Yes,
on
first
board.
ever podcast. Thanks for having me.
Pleasure. All right, let's begin with where you work and what you do.
Yeah, so I'm a postdoctoral researcher at the Technical University of Munich, and I'm also the author of TorchGeo. So most of my time is kind of managing geospatial software libraries for
Mm.
machine learning.
Mhm. And for people that aren't so familiar with TorchGeo, what's the elevator pitch?
So if you're familiar with torch vision, it's the same thing for satellite imagery. If you're not familiar with torch vision, basically in the PyTorch ecosystem, you have PyTorch itself, which has all the basic building blocks you need for deep learning. TorchGeo is all of the high-level abstractions specific to geospatial data. So the data loaders, the foundation models, transforms, and PyTorch Lightning modules for actually using all of these things in combination.
Right. So it basically is the toolkit you need to work with geospatial, handles all those kind of geospatial specifics,
Yep.
enables you to do things like just load data sets, train models. Have I missed
Yep.
anything there?
And a lot of people ask, why can't I just use Torch Vision? It's all images. Um, TorchGeo is really designed for things like multispectral images, hyperspectral images, which don't have three bands and don't work with Torch Vision
Mm,
transforms or don't work with Torch Vision models. So it's really hyper focused on these kind of obscure image data sets where you have to deal with
mm.
things like reprojection and resampling, aligning to raster and vector data sets, automatically rasterizing a vector data set. So there's a lot of complexity in geospatial data that doesn't exist in typical image data sets.
Yeah, those people don't know how lucky they are.
Yeah.
Right. And it's a very popular project. I mean, what are the stats at the moment?
Yeah, so as far as I know, I think it's safe to say it's the most popular geospatial machine learning library. So there's 3,500 stars, over 100 contributors from around the world. We've had about 500,000 downloads in total since the project started. So yeah, it's
Mm,
been quite successful, much more successful than I think any of us expected.
that's great to hear. And recently, there's been a few key updates. Maybe we want to just fire through some of those.
Yeah, so as of yesterday, at the time of this recording, we just announced the TorchGeo organization. So this is something we've been working on for over a year now. Basically, when TorchGeo started 4 years ago, it started off as my intern project at the AI for Good research lab at Microsoft. And we made it open source. We thought it'd be useful for the community. And we were actually really surprised that it turned out to be very useful for the community. A lot of people picked it up, started using it, started building other libraries on top of it. Um, and with all of that, with the kind of competition over who has the best foundation models, who has the best software libraries, we've noticed there's a lot more competition than collaboration. And one of the things that we wanted to do was make TorchGeo even more open. So it's already open source under an MIT license. We wanted to also have open and independent governance so that it no longer belongs to Microsoft. It belongs to all of you, the TorchGeo contributors.
Mhm.
So this is something that took a very long time. Obviously, there's a lot of people at different levels of Microsoft who need to approve this, different lawyers we need to talk to. It was actually Microsoft's idea to set up this governance panel. So they suggested this minimal viable governance model that GitHub published, and we decided to adopt that, made a few changes here and there, but otherwise set things up. So the current, uh, so there's two different things to be aware of. There's the TorchGeo organization, which governs the TorchGeo project. The TorchGeo organization is led by the technical steering committee. Currently, we have six people. So there's me and Niels from Tomb. There's Caleb and Anthony from Microsoft. And then there's Isaac from Whereabouts and Ashwin from Space 42. So these are the people currently leading the entire TorchGeo organization. And then approximately the same set of people is also the maintainers of the Python library itself.
Mhm.
There's a lot of other reasons we wanted to do this. So, TorchGeo itself, the Python library, is not the only thing that we manage. So we also have a Hugging Face community, a Zenodo community where we upload data sets and models. We have our Slack workspace, obviously, where we have a code of conduct that we need to enforce. And we would also like to grow the TorchGeo organization to have multiple projects in the future.
Hmm.
So in the medium range future, I'm managing a few master students who are actually working on GIS integration for TorchGeo. So
Hmm.
imagine loading up QGIS or ArcGIS and chatting with a vision language foundation model and using it to automatically label your satellite imagery for you.
Hmm.
So that's something that's coming probably in the 1 year time frame ish, long after all of the other stuff we're actively working on right now.
Right. So sort
So
of.
that would also be something that they would govern.
Mm,
So the current technical steering committee is those 6 people. We do want to grow this in the future. So if any of you are wondering how can I take part, especially other libraries that are built on top of TorchGeo who want to have some sort of say in
mm,
backwards incompatible changes or release schedules. Um, it's quite easy to join all of our technical steering committee meetings. They're all open to the public. Just join the Slack workspace and join the technical steering committee channel.
mhm,
Um, in terms of actually onboarding people onto the technical steering committee, we'll probably start slow and onboard more people one at a time, but we do actually want to grow the technical steering committee to have more diverse leadership.
mhm,
So we've got people from big tech companies and startups. We've got people from academia. We're really missing people from government labs. So we would love to have people from NASA, ESA, DLR, USGS, NOAA, all of these other government agencies that actually provide the data and provide a lot of the expertise for pre-processing and using the data. We would love to have them as partners as well.
It sounds like it's really setting the foundation for the future development objectives and also just broadening the sort of engagement.
Yeah, exactly. I mean, if you think of it this way, if, I do a lot of research on satellite imagery for agriculture. And if it was only me making decisions, we would only have agriculture data sets, only have agriculture models.
Hmm.
But the more people we have from different application domains, different experience levels, people who are only computer scientists who don't understand anything about satellite imagery, people who are only remote sensing experts who don't know any machine learning.
Hmm.
If you don't have a more diverse community leading things, you end up with documentation that only works for one audience or features
Mm,
that only cater to one audience.
absolutely. And is the provisional plan to have meetings periodically? What did the committee actually do then?
Yeah, we'll have meetings once a month. It will probably be the first Monday of the month at 6 p.m. Central European time. I think next month we're going to shift by a week just because of Labor Day in the US.
Mm,
But other than that, yeah, we want to meet every month. We want to have it open to the public. Everyone should come and join and just chime in and say, hey, I'm using TorchGeo, but this feature isn't working for me, or why don't you have this feature? Or I'm interested in actually contributing. How do I get started? What do you
hmm.
need? Questions like that are always open, always
Brilliant.
welcome to the audience.
Okay, not long to go till that first meeting. There's
Yep.
also some other changes coming.
Yes, the biggest thing that we've been working on, and this is also almost a year in the making. I think we started pretty heavily in October. Um, we really looked at the features that TorchGeo has and looked at the stability of TorchGeo, and we said, things are starting to stabilize, especially as other software libraries build on top of TorchGeo. They want some guarantee of backwards compatibility. They want more deprecation cycles long term. So they want something close to a TorchGeo 1.0 release where we can guarantee some level of stability. In terms of the features that we have most of the things that we want. But I think the one major feature that we're still missing is complete time series support. This is something that is lacking in almost all GeoML libraries at the moment. I think the only shining example would be SITs from the R ecosystem, where they're basically focused solely on time series support and
Mm,
very good time series support.
hmm.
So we tried to take inspiration from SITs and other libraries that have tried to do time series support and looked at how we could integrate it into TorchGeo. Um, when I mention time series support, I'm talking about many different things. So there's 1D time series support. So imagine you're working with a weather station or an air pollution sensor, and you want to forecast future levels of air pollution at that specific location. So that would be the 1D example. In terms of 2D, TorchGeo has always done 2D, so that's quite well covered. But we also want to support 3D. So imagine you have um, a location that's been damaged by some sort of natural disaster or by warfare, and you want to do change detection. So you have two timestamps for one location, two images before and after, and you want to label damaged buildings
Hmm.
or places that you should target for recovery.
Hmm.
But also moving beyond the two timestamp, we want to support multiple timestamps. So let's say you're doing something like crop type mapping, where you've got an entire year's worth of Sentinel-2 imagery, and you actually want to take advantage of both the time dimension, but also the spatial dimension. So
Hmm.
that's the 3D case. And then there's also the 4D case, which is becoming more and more popular, where you're targeting things like medium range weather forecasting, nowcasting, even decadal scale climate modeling.
Hmm.
So here you have the X and Y dimension, but also the Z dimension for altitude, and then of course the time dimension as well. So all of these are covered under time series support, and we actually chose these specific applications to really highlight the fact that TorchGeo is not only for satellite imagery.
Hmm.
Obviously, most of the data sets, most of the features that we add are targeted towards satellite imagery, but we just merged our first weather forecasting model where we have many data sets for point data and a lot of other very interesting applications.
Hmm.
So that's everything that's covered. Again, this is something we've been working on since last October. So there's a lot more work involved in this than any of us really expected.
Hmm.
Um, I started looking at some of the back end design of TorchGeo that I came up with 4 years ago, and I was like, why did I do it this way? This is so inflexible. It's just not practical.
Hmm.
So, for example, we used to use Archery for all of our spatiotemporal indexing. So we did keep track of the spatiotemporal bounding boxes of all of our files so that we could sample them quickly and efficiently.
Hmm.
The problem with that is that Archery lacks a lot of features that we need. For example, we want to be able to separately index space or time, not both at the same time. So we did a very long and intensive, basically software literature review on all the options available to us. We looked at Archery, we looked at Shapley's STR tree, we looked at GeoPandas, and then we also looked at the Stack ecosystem and tried to find something that was a little bit more flexible, more powerful, and had a lot more features that we could use for this. So we ended up switching to GeoPandas. So I basically had to rewrite every single geodata set and geosampler from scratch to work with GeoPandas.
Hmm.
Um, at the same time, we're also looking at the data loaders, how they load the data, what data they're able to load. We previously used Raster.io for all data loading, and Raster.io is great because it wraps around GDAL, and anything that GDAL can read, TorchGeo can read.
Hmm.
But there's a lot of things that we want to be able to read that aren't in that list. So, for example, a lot of the weather and climate data is stored in NetCDF, HDF5. Technically, GDAL can read these things, but not the version that's on PyPy. So we
Hmm.
started looking more and more at Xarray, and at the moment, I'm working on a pull request to actually replace Raster.io with Rio Xarray so that we can load anything that Raster.io can load, anything that NetCDF or HDF5 can load, and have a little bit more flexibility. We're also planning on replacing Fiona with GeoPandas so that we can drop some of these dependencies that we no longer directly rely on. They
Hmm.
become indirect dependencies where there's higher level libraries that wrap those instead.
Right.
So this will also help a lot for scalability. Things like GeoPandas and Rio X-Ray have really good integration with Dask. You can very easily parallelize them. They scale up quite well. So there's a lot of very big back-end changes that are very backwards incompatible. That's another reason why we wanted to make this 1.0 release where we say, hey, we're changing the major version number. This is a very big change. Expect things to break. We will be making release candidates before we make the official release so that people can test them and make sure everything is ready to go for
Hmm.
the official release. But basically, everything related to GeoDataset and GeoSampler is probably going to break. The rest of the library doesn't change so much. It should be mostly backwards compatible. We're also adding a lot of new features. So, for example, we just merged a new change detection trainer. So you can do binary, multi-class, and multi-label change detection now with TorchGeo. We've got a bunch of change detection models that we already have integrated with that, and we're expecting to add more as well.
Hmm.
And we're working on an auto regression trainer that you can plug in for things like air pollution forecasting or weather forecasting,
Hmm.
where you can integrate all these existing foundation models.
Hmm. Wow, it's a really exciting set of features, and I think, as you mentioned, kind of unique in the ecosystem as
Yep.
well. So it's partly about features, but also about saying now, now the foundations are there. This is 1.0, and we're going to make some backward compatibility breaks, but also guarantees for the
Yep.
future. It's interesting
And
because,
I think I talked to some of the folks from PyTorch Lightning, for example, and one of their philosophies was, get your software to a point where it's stable and then move on to the next big thing. And TorchGeo is not going away. We're going to continue to maintain it for the long-term future. There's a lot of other features that we do want to add in the near future, things like stack integration that they're not necessarily backwards incompatible, but they're much needed features. But we wanted to get it to a point where it's relatively stable, where I, as the main developer, can take a step back and say, I'm going to review PRs, but I want the community to really lead these PRs and do a lot of the work.
Mhm,
And while that's happening, I can explore new things and say, I want to target GIS integration for this low
mhm,
code, no code environment for non-computer science experts.
mhm,
Um, this is one of the things that we've gotten a lot of, kind of, I wouldn't say criticism, but jokes about where TorchGeo is the best library ever for a machine learning expert. But for a remote sensing expert, there's a lot of things in TorchGeo that are still quite hard to wrap your head around.
mhm,
What is a geosampler? Why would I need it? What is a PyTorch data loader? What is PyTorch Lightning? Why do I have to learn all these new things in order to
mhm,
do machine learning on data? It's obviously much more complex than a simple scikit-learn workflow.
mhm,
So we wanted to take a lot of the abstractions that we have with PyTorch Lightning and bring those to the remote sensing audience in a way that's much more accessible.
mhm. Exciting. You briefly mentioned that TorchGeo is built upon by a few other libraries. Do you want to just list some of those and maybe talk about how they
Yeah, so the
relate?
big one that I think a lot of people know about is TerraTorch, but one that actually has even more stars is GeoAI, and then also the GeoBench benchmarking suite uses TorchGeo to curate many of its data sets.
Hmm.
NASA's PyTorch Caney uses TorchGeo a little bit for data loading. So there's a lot of different organizations that are building on top of TorchGeo.
Hmm.
One of the reasons we wanted this independent governance is so that it's easier for those people to build on top of TorchGeo, but also we would love those people to join the technical steering committee meetings and eventually join the official technical steering committee board.
Hmm.
So we would love folks from NASA, from IBM, from all of these other different institutions to join and help kind of drive the future directions of TorchGeo so that we can collaborate. We're not reinventing the wheel. For example, TerraTorch has a bunch of data loaders, but what they really shine at is building on top of TorchGeo, adding these higher level abstractions for basically building a foundation model playground where you can fine tune and evaluate your foundation models much more easily than you can directly in TorchGeo. So we would
Hmm.
love to take some of the more experimental features that TerraTorch has and integrate them more directly into TorchGeo, but also offload many of the things that they don't want to maintain themselves so that when there's big backwards incompatible changes to the data loaders, we fix them, not them.
Hmm. Right. So coordination will definitely benefit all
Yes.
parties there. One topic that's getting a lot of interest at the moment is foundational models, and I think I've seen an increasing number of foundational models being supported in TorchGeo. What's your take on foundational models?
Yeah, so I'm obviously biased because I'm a foundation model researcher. So I've been involved in quite a lot of foundation model projects over the years. The first one I got started with was SSL for EO Landsat, which was really the first foundation models ever pre-trained on Landsat imagery and the largest Landsat pre-training data set ever created, and I think maybe still to this day. So we created 5 million Landsat images for Landsats 4 through 9. We had several different foundation models of, different ResNet and vision transformer backbones, different SSL techniques, different generations of Landsat satellites, different surface top of atmosphere products. We basically had 40 foundation models for Landsat. And one of the things that reviewers said was, what's the point of 40 foundation models? Shouldn't you just have one foundation model? Like, isn't that the definition? And back in that time, like foundation model was really just a big buzzword for any large model trained on a lot of data, usually using self-supervision.
Mm,
When I joined the Technical University of Munich, one of the things that I wanted to do was we've got a lot of foundation models for Sentinel-1 and 2. We now have some for Landsat. There's still thousands of other satellites out there that we're not covering. We
mm,
really want foundation models for every satellite, not just the most popular ones.
mm,
And one of the things that really intrigued me, one of the reasons I joined this lab was that there was a lot of really exciting stuff going on with foundation models here.
mhm,
So right when I joined, DOFA was already well underway. So DOFA is the dynamic one for all model. It's this neural plasticity paper that people might have seen on Archive. Basically, the idea with DOFA is that you can encode use a dynamic hypernetwork to take the wavelength of each spectral band as input and dynamically generate the first layer of your vision transformer so that as long as you know the wavelengths of your spectral bands, this single set of pre-trained weights works for every Earth observation satellite ever launched and that will ever be launched in the future.
mm,
So this is an extremely powerful, flexible multimodal model, really the first such multimodal model that existed. There's been a lot of other things since then that I've been involved with. The Copernicus Foundation model, which supports Sentinel-1, 2, 3, 5P, and Copernicus DEM, where we're adding in a language encoder, allowing us to support non-optical modalities. Panopticon, which takes a lot of the ideas of DOFA, incorporates a lot of the ideas of Dino V2, and generally makes a more robust and more powerful foundation model.
mm,
We have DOFA Clip, which is a real vision language model where you can do zero-shot learning, talk to your model, and ask it to label your data for you without any fine-tuning required.
mhm,
So these are the things I've been involved with. As you've noted, foundation models are the latest and greatest buzzword. There's a lot of hype centered around this new concept. Everyone wants to get into foundation models. At the same time, the hype is obviously bigger than what it's delivering. There's still a lot of people saying, it's great that you've spent millions of dollars training these gigantic foundation models on tons of compute, tons of data, but my random forest model still works quite well. My
mm,
my supervised unit still works quite well. And I think the things that are really missing in that discussion are the scientists. So, a lot of the higher profile things I've seen recently are things like, I tried comparing all of these foundation models to just a regular UNet, and I trained them on Big EarthNet, and UNet worked better. So foundation models are useless.
mm,
And what people don't realize is one, you're doing supervised fine tuning on one model and linear probing on all the other ones, and that's not a fair comparison. You can still do supervised fine tuning on your foundation models, and the real benefit is that you can learn much quicker. You already have a very good start. So you can fine tune directly from pre-trained weights instead of random weights. That's a huge
mhm,
advantage for anyone who's not a machine learning expert. But also the data set sizes that real scientists work with are orders of magnitude different than something like Big EarthNet, which has 500,000 images in it. So a lot of scientists I talk to, they come to me and say, "Hey, I want to get into deep learning. I have this huge data set that we've collected over the last 5 years. It has over 100 images in it. How can I get started?"
mm,
And when you hear those numbers, you say, well, huge means something very different to the deep learning community. But now that I have these foundation models, 100 images is actually sufficient for the first time for really fine tuning for these very diverse applications.
mhm,
So I do think that foundation models show a lot of promise. I also think there's a lot of hype around them. I'm hoping that the hype dies down so that we can actually start collaborating. Um, as you've noticed, like there's a lot of promise of one foundation model to rule them all. And in no domain is there one foundation model. In language, in vision
mm,
language, there's always competitors. There's always people competing for the latest and greatest. I don't think that's going to change anytime soon, but I'm going to sit here and eat my popcorn and enjoy the ride and just keep adding more and more foundation models to TorchGeo so that it's easy for people to use them and easy for people to compare them.
Right. So really supporting all those investigations and making it a
Yep.
bit of a hub where people can.
And we also have a lot of these pre-training data sets in TorchGeo. We have things like seasonal contrast, SSL for EO, S12, and Landsat, Copernicus pre-train, Big EarthNet. We have a lot of the data sets that people need to pre-train these models. We
Mm,
also have a lot of the data sets that people need to evaluate these models. So Copernicus Bench, SpaceNet, and we would love to add a lot more of these higher order meta benchmark suites that combine all of these individual benchmark data sets.
mhm. I guess one last question on the foundation models. You mentioned about the linear probing versus fine tuning.
Yep.
Is TorchGeo going to stay focused on one or the other? Like, for instance, people interested in just using embeddings. Is that something TorchGeo would get into, or?
So two questions on the linear probing versus fine tuning. We do support both, and we don't have any personal preference. So, for example, if you use semantic segmentation task, you can tell it to freeze the decoder or freeze both the encoder and decoder and only do linear probing at the end layer.
Mhm.
Or you can fine tune the entire thing. So we're pretty flexible. We want to remain flexible. All of these are good use cases. Really depends on how much compute you have, how much expertise you have. Choose whatever works for you and use it. We would actually like to make that more flexible in the future, and I think that's something that TerraTorch has done quite well.
Mm,
So depending on, how we end up collaborating with folks from IBM, we would love to make that even more flexible in the future.
mhm.
On the topic of embeddings, a lot of people have gotten really excited about embeddings recently after the release of Google's embeddings. I think Presto also released their own embeddings recently. Major Tom had embeddings long before both of those. So I do think that embeddings are the future. We are building embeddings for our own Copernicus Foundation model, so we want to have embeddings that not only incorporate satellite imagery, but also incorporate things like ERA5, which I don't think anyone is really trying to do at the moment.
Mm,
So embeddings are a really nice opportunity to take away a lot of the computational load from domain experts so that they can rely simply on a learned embedding, a low dimensional representation of a location somewhere on Earth and
mm.
focus more on the decoder side. So there's a lot less compute required. At the same time, embeddings are definitely in their infancy. There's a lot of issues with the Google embeddings, with all of the embeddings that currently exist. So just like there's a lot of progress that still needs to be made in foundation model research, there's a lot of progress that needs to be made in embedding research as well.
Brilliant. Well, thanks for sharing your opinion on those topics. It's been a really fascinating conversation. So much going on, so much potential, I think, still there. Obviously, TorchGeo is on GitHub. It also has a website. You mentioned the Slack channel being a place where people can go and connect with the developers as well. Any other places that people should look to connect and follow along?
Yeah, that's most of them. I mean, you can email me, but I will eventually reply. If you
Mm,
message me on Slack, I'll actually probably reply quicker. If
mm,
you message me on GitHub, I might actually be on GitHub right now answering your questions.
mhm.
So those are definitely the best places to reach out. If you go to the GitHub, which is github.com/torchgeo/torchgeo, there are links to all of these other communities. There's a link to join the Slack channel. There's a link to join the Hugging Face community. You can join and participate in discussions and help drive future development of TorchGeo.
Brilliant. Okay. Well, once again, thanks for joining me today, and I look forward to connecting in the future.
Yeah, thanks for having me.